Hello everyone. I'm Bruno and I will try to speak in English. We are going to speak about robots, but first, let's see what it means. No. This one is now. So this is now, you have seen it since yesterday, you will see it later on. This one is Pepper, the new one we released, Aldebaran Robotics. And we have another one called Romeo, a larger size one, 1.4 meter. We are doing this robot because for a long time, we think that there must be robots everywhere. I was dreaming of having robots everywhere for a long time, as much of us. But in fact, it's so difficult that there are no robots. So now we decided to first design and build a platform, and after that improve it till having the correct level enough robots. So I will explain you what they are for, what you can do if you want to join the adventure. So sorry, I'm a little bit exhausted with these jet lags and so on. So I started creating robots about 35 years ago, when I was very young, and I founded Aldebaran, our company, in 2005. Aldebaran, you know the name of the company, it's the name of a star, because stars are at the same time science, future, hard science even, but it's also dream, it's also poetry, new territories to conquer. So Aldebaran, our goal is to make robot helping people. But we could have chosen to have vacuum cleaners. We could have chosen to have defense robots that are helping people. It's not what we have chosen. For us, the most valuable thing is to have companion robots interacting with people and helping people growing, entertaining, connecting to the other part of the world. I will explain you a little bit that later on. So we have designed robots that we call emotional robots, in the sense that this robot is able to interact with people very naturally, to connect them, and because it's an emotional robot, then it's a robot that people will want and will accept to have at home. So it's a new concept we've created. Other companies designing robots are doing other things, and this concept turned us world leader. So we are a French company based in Paris, and we are world leader in robotics for now a few years, founded in 2005. This now robot is the first companion robot we've designed. It's already used by prestigious universities such as MIT, Stanford, Tokyo, Shanghai, Beijing, Cambridge, Polytechnic in France. So they are all using this robot, this first companion robot, and now there are more than 5,000 around the world. So it's turning a mass product, well, small mass, very small mass, a confetti product. It's a very, but it's turning large volume. We are able to produce thousands. So now we are going to go much further on and much faster with these robots. So let me explain you a little bit more what these robots are for us. There are many things at the same time, these robots. They are what we are calling ultimate interface. They are cute companion, and they are evolving robots. Very important that. If I'm speaking as ultimate interface, there are robots that can choose the appropriate way to interact with you, being by body language, by voice, of course, and by emotions. It's important to have that, because if I want the robot to be very natural at interacting with people, and not only with geeks, to interact with everyone, it has to have a fully natural way, including this body language, including the fact that, well, when I'm saying yes, but I'm very excited, or I'm saying yes, but I'm very sad, it's not the same meaning. So the robot must react differently. When I'm saying yes, and I'm meaning no, it's another thing that the robot is able to detect, or sometimes able to detect, and this will grow. So this is all the system we have behind. We've invented, on top of voice recognition system, we've invented what we are calling our emotional engine, based on algorithm, analyzing facial expression, smiles, analyzing all the body language, analyzing the tone of the voice, gesture, all these questions. So it's a multimodal engine, taking all these inputs, and based on these inputs, able, as of today, right today, to say whether the guy in front of the robot has positive emotion or negative one. So it's already something, it's already working, but with this limitation, and we are improving to add new dimension of emotions. So as of today, we already have this multimodal system able to tell if the guy in front has positive or negative emotion, which is great for learning, because it's giving us a feedback. It's giving the robot a feedback whether what he did was great or not, what he did was appropriate or not. So it's helping the robot growing. And besides this emotional engine, we have another one to express what he has to say. Of course, we have speech technology like everyone has, but we've created another one for providing body language to the robot. So if you are programming what the robot is saying, so sometimes it's programmed, then you can make the movement accordingly with what you want to say. But if you ask the robot to read mails or to read the news or to read I don't know which document, then you have the robot by himself to have his own body language automatically. Because I don't want to see dead bodies, dead robots, not moving at all. It's scaring, it's not pleasant, you don't want to have that at home. You need to have an artificially alive robot. It has to be moving, it has to be autonomous, it has to have his autonomous life, but it has to have something. So the robot, now our robots are able, thanks to our expressive engine, able to decide by themselves or to create some adapted motions. So if you are combining the both of them, this emotional reading or dialogue system plus expressive system, then you have a perfect interface, totally natural to interact with. Hey, come here, you can make gesture, you can make, so it's a very good way to interact, very easy, very natural. So the second thing is, it's a cute, they are cute companions. When you look at our robots, you've seen them, so they are, okay, they are pictures. They are cute robots, but cute is not just because we wanted them to be nice and people to like them. It's much deeper. I want people to want them at home. And not only geeks, as I said. I want everyone to say, wow, it's so cute, it's fantastic, I want this one. And these robots have to be friendly, positively friendly. In French, the best word would be benevolent, but I think the sense in English is not exactly the same. But kind, nice. They have to be your friend, your artificial friends, but they have to be your friends. Then you will accept them. So we did that because we worked very hard on the design. Design is at the essence of what we are doing. It's fundamental to have design for the acceptability. And design is not only a question of look, it's a question of design of movements. You've seen the very nice and very cute movements. It's a question of design of applications and behaviors. So when you are combining all that, then you can get a very, very cute, fluid, friendly robot. And this is key to have acceptability. One more time, very important is to have people willing to have this robot at home. But now they are more than just friendly. They are also genuine. That means ethics is at the core of what we want to do. The last thing people will want to have is a spying robot. You know, a robot that will listen to you, discussion with your friends. Oh, I'm wondering whether I want to buy a new car and so on. And you receive advertisement about cars and so on. Oh, you don't want that. So you don't want spying robots. Ethics is very important. So we are committed to protection of personal data, respect for privacy, environment, all these questions as much as technology allows us. And we know that there are some limitations. So that means we are embedding in our robot some physical strap or things that will allow or not to plug the antenna, allow or not the robot to be able to communicate. So if you don't want your robot to communicate, then you will make it physically. So no hacker will be able to overpass that because it's physical. So you will have the choice. If you want, of course, it will give you less functionalities. There are many things you won't be able to have. You cannot have everything at the same time. But then you are protective if you want. And if you accept that, then you can have all the other possibilities of your robot. I don't know, storing your data, and then storing your data away. Imagine the robot can store data of what's happening. You have birthday parties, you have event at home. Robot can store all these data, but he can store these data accordingly to the emotional charge émotionnelle, emotional load of what's happening of this event. I don't know if you have friends coming and going out without anything. Okay, robot can just remember and register as friends came at that time. Okay, but if it's a birthday with people laughing, crying, or whatever, then he will register everything, high definition, high resolution, in order for in the future be able to get back that to you. Okay, so it's very important to have this question of ethics and this question of design. They are cute robots. And finally, the third pillar is they are evolving robots. Our robots are not just another technological product. They are more like an artificial being. Artificial being able to evolve, to learn, to grow, to surprise you every day more and more. And we did that. It's absolutely fundamental. You probably all know the Aibo from Sony. It was a fantastic product, very nice, great. But after 3 weeks, you get bored with it because it was doing always the same thing. It was not evolving, it was not changing. Of course, we want to embed a self-learning system, but it's not state-of-the-art, not correct. So we did that through our application store. Well, it's obvious, but we did that way. So we have an application store allowing the user or the robot by himself to download new application, new behavior, and then evolve. So this is providing many new possibilities to the robots. And of course, we are interested and we want to have as many people as possible interested in being part of this adventure, in joining us to improve, enhance what is in this application store. develop new application. So being developers, animators, sound designers, there are many areas that are interesting to embed in a robot. It's not just development. Animation is something special. Communication code is something special too. Psychologists can be useful, sociologists can be useful. So many people can join us, be part of this adventure, and then use our fantastic operating system we've designed. It's called Naoki. We have designed our own humanoid operating system with all these emotional functions, with all these interactive functions, and we have tools to program all that. We are opening what we are calling Atelier. We are opening Atelier for people, places where people can discover these robots, can experiment, can play with the applications, and there is a space for developers where they can get together and help each other and together change things. So we hope it will be turned as the house of the developers where there will be. The first one will open in Paris, end of June, 26th of June. Second one will open in Tokyo, Omotesando, mid of August. The third one in Tokyo, Akihabara, mid of August too. And then it will be in the States, but probably next year, California and New York City. Okay, so now you can see the next steps. If we join together what I said, very cute robots that people like and want at home, very easy to interact with, and connected to the internet. Wow, imagine all what we can bring to people. That means all the application for education, for healthcare, for health coaching, for, I don't know, entertainment. Of course, the future of video gaming is in robotics. We know that this business is not growing as much as it was growing, is beginning even to reduce. And this video gaming industry is coming into the physical world with the Wii, with the glasses, with whatever. They are coming into the physical world, but the next step will be robots. So the future of this video gaming industry lies in robotics. Monitoring, to give some examples. In Europe, we've had in 2003 a heat wave. I don't know whether you remember, it's far away. 70,000 people died. Why? They were old people living alone, and nobody told them it was drier and hotter than usual, so they have to drink more. And when they fall down, nobody was here to call for a call center. If they had had a robot, we will have avoid 70,000 dead people. But not each and every robot. We just needed at that time a robot that people would have accepted at home. Acceptability is absolutely key. So when you have acceptability, then you can open a lot of businesses. And who will do these businesses? Of course, some companies, some people, developers. Well, the same story that happened with the PC, with the mobile phone, is going to happen again with the robotics. So now, if we think about the way that now or Pepper, our two robots, but others, will change our daily lives, it will be kind of, well, I don't like revolution, but it will kind of drastic evolution, the same magnitude that happened with the PC, with the internet, and with the mobile phones. Remember the first mobile phones? How heavy they were, and how smart and light they turned? Remember the first internet? I remember in '93, first internet coffee, I was there to connect to the internet, how slow it was and how fast it changed the world. The same story is going to repeat again with robotics. And everyone knows that. All the investment funds, everyone knows that there will be a wave, a new wave of robotics that will change things. It's one of the next big things. But for everyone, it's so difficult to develop robots. It's so impossible to turn them affordable to people. Even more humanoid robots, then that it's for the next 10, 15 years, what they think. But the fact is, we already have these robots. They are already existing. They're worth around $2,000. They will be sold large volumes, consumer market, in Japan first in February, next February. And after that, roll up in other countries. So that means it's right now, it's happening right now. And all the people who are interested and who are expert in one elementary brick, I don't know, someone is expert in vision system analysis, another one is an expert in expressivity, in voice analysis, in navigation, or user interface, or just want to develop applications. So as of today, no one could do that because you didn't have a correct robot. We know that there is a Asimo from Honda, a fantastic robot, $1 million, okay? If you want, you can. There are this kind of robot, but research prototypes, they are not robots for everyone. So now that there are robots for everyone, I think a huge community will come, jump on this product, help improving, and it will be exponential. Because everyone will add something, helping, improving and increasing what the robot can bring. So it's something that is happening. We are just at the beginning of the story. These robots are existing, but they can be improved. Emotional engine is existing, but will be improved. Dialogue system is existing, but will be improved. It's just the beginning, but it's already existing. It's already interactive. You will see what those robots can do right now, how you can come, jump, help us, improving the robot, take advantage of that. So it's something that will change the world. It's the future, but it's already the reality today. Thank you. I think we will demonstrate you something about our robots for you to understand better. And after that, there will be questions if you have. T'as besoin d'un peu de temps ou pas? Ou je leur demande une ou deux questions? Okay, so he has to prepare himself. So are there one or two questions in between?
I know you're trying to get robots in the home, but one of the biggest roadblocks is obviously the price. Is there any initiative for developers, for example, since you're trying to kickstart this app store or market? Is there any initiative or incentive or discount for developers to actually get a robot?
Okay, first of all, the price, less than $2,000, I think it's a good beginning. It's turning acceptable. For the developers, we'll have developer conference explaining everything and the detail of the SDK and so on. And we are thinking about having some kind of plans. The idea I love, but I'm not yet ready to implement it, is to say, okay, for developers, we could have a robot bought by registration. Okay, let's pay, I don't know, $200 per month or $100 per month for a few months. And once good applications are uploaded, then it will relieve you for paying the remaining. So it's something that will motivate people, incentivize people to develop good application. I don't want them to be the one that who will say application is good or not, because I'm part of the story. So I will need to have average of the community giving notes or something like that, ranking the application. But it's something we're thinking about. But it's not yet finished.
Do you personally have a robot at home?
Yes, I do.
Is the physical robot necessary to develop something, or do you have some kind of simulation engine so that we can develop a behavior and try it just on the computer?
We have simulation engine, we have software that allow to do that without having the robot, but it's not the same at all to interact with a real robot. If you have simulators, you can imagine things, but the real world is very complicated for a robot. All the sensors are noisy sensors, which is normal. Our sensors are very noisy sensors. Our ears are very bad quality. And it's because we have our brain completing what the ears are receiving that we're able to understand. So, but world is complicated for robot. If you are not having a real robot, you will do things, it will be nice, but it will be like a video game. It won't be a real robot in the real world. But you can do and begin with that before jumping to a robot. So later on for the other questions.
Thank you. Hello, I'm Gwen. I'm a software guy that I've been working for 5 years in Aldebaran. And I'm now in charge of building and putting the pieces of a new operating system into the robots in order for you guys, for the community to develop applications. So I'm going to show you what it means developing applications. So you have understood maybe that the challenge is to draw that hurt in between robots and users. We need for that great apps, as Bruno said, but we also need some sort of operating system to trigger these apps, obviously. So just before going on the apps side, I'm going to give you a few words about the operating system. Why reinventing the wheel? There is many operating systems existing in the world, but we think we had to develop a new one. And I'm going to explain why. Laptop and tablets are basically based on screens. Either you touch the screens to put some inputs into the system, or you get some display to have some expression out of the system. And they're also user-driven. You are not expecting your mobile phones to launch the Facebook application if you did not touch the Facebook icons, obviously. We don't want that on the robots. In terms of interfaces, we do not have screens. And we want voice, gestures, emotions to be used as input and also as output means. And in terms of launching applications, yes, we certainly, in some situation, want the robots to understand some orders, like launch the Facebook application, for sure. But we also want the robots to have its own, intention, and to sometimes, if the robot sees a crowded room, maybe launch by himself some sort of a dance, So it's both user, but also robot-driven. And because, at least of these two reasons, we designed what we call NaoKey-OS. NaoKey-OS is an operating system that runs on Nao, that runs on Paper. Paper is now deployed in Japan, and what is running in his brain is that OS, and is also running on Romeo. In terms of input and outputs, obviously, we've packed into that operating system big bunch of state-of-the-art perception algorithms. I put some few examples on the on the left, sorry, but we have state-of-the-art speech recognition engines, face recognition. We are able to perceive people. I will show you that later. And as Bruno said, on the out side, we also have state-of-the-art text-to-speech features. But we also design some in-between engine, dialogue engine, navigation engine, emotional engine. Right? So that's the first specificity of our operating system. But all these services are just here. They are exposing API. So, but API means that if nobody used the API, the robot is just dead. You have a dead robot here. His head is full of potential, but there is no application running here. So to bring a robot to life, we put activities. We focus on activity. But the question is, okay, let's say that we have many activities, many applications installed in the robots. We want some of them to be focused, but who is going to choose? So we design just two small additional bits here that are here to suggest to the robot some good activity to launch, right? That process is pretty simple. A first step is to suggest some applications, and we also have what we call the mind prioritizations, because obviously many, and especially if you have many activities, it's likely that you will have many activities wanting to launch at the same time. So we have a way to, to prioritize. But this middle thing is the way that the robot is launching himself, his applications. Of course, if you are a developer and you don't want to be bothered by a living robot on your desk, you can, of course, disable that temporarily, really. So I'm going to show you that. Creating an app. So let me switch microphones. This is Choreograph. We have different languages. Everything. I'm going to show you the SDK through Choreograph, but you could do exactly what I will be doing in 10 next minutes with C++, Python, Java, or JavaScript. I'm just using Choreograph because it's easier in 10 minutes to give you a quick tour. I'm currently connected to the robot on the table. I can move his head. Well, if I'm turning that on. I have a full control about the robots. By the way, the robot is now running its autonomous life. So there is really few applications running, but you see that the robot is looking for something. And if I approach the robots, now, now, and if I get closer, can you see me? So yesterday I just put a very simple applications, and I designed that application so that when you approach it, the robot automatically triggers it. So we are going to play with that a little bit. So in choreograph, you have a predefined list of boxes with predefined actions. We have maybe 200 of them, so I won't go through all of them, but let's say that I want to have the robot say something. I'm just drag and dropping the say box, customizing the text. Hello, I said hello QCon. Just run play. Oh, sorry, up.
Hello, QCon.
So yeah, QCon was not really well understood. But that was just a dead robot saying hello QCon. If you want to improve a little bit, I'm going to extend that. I'm going to grab a different type of box called animated say. It's exactly the same box, but with the expressive engine on, and you will see the difference. Wow, that's very small. Yeah, I just written hello, I'm happy to be here.
Hello guys, I am happy to be there.
So, my now broke his arm yesterday, sorry. So you've seen that it was not only a robot saying, hello, I'm happy to be there, but he also animated himself, is what he said. I mean, I could have fine-tuned the animation during the text, but it was not needed here. It was all automated. So that's a very basic example. So now, let's say that I want to prototype a basic game. I want to first make sure that whenever the application starts, I'm sure that I have somebody in front of the robot, not to speak to nothing. So I'm dragging and dropping a detect user box. Then, if I saw somebody, I want to say something. Stuk. Just to confirm that it's okay, I saw somebody. I saw somebody. Poor guy. Then, once I have somebody in front of the robots, I'm going to launch a age and gender detection. It's a state-of-the-art technology to estimate the age and the gender of the user. And I know that it's kind of a touchy, touchy algorithm. So, but that's the concept of my game. So, depending on what the robot is going to say, I will make sure that, yeah, that's the right one. So that little say box is going to out loud to pronounce what the engine will have detected. So the robot will probably say, "Oh, you are 20, and you are a female," or something like that. Depending on the results, I want to know if the user in front of me is, in front of the robot, is either happy or not. I could have drag and drop a class. Pretty common speech recognition interface. Just, are you happy with my guess? Yes, no, but it's kind of boring. So I decided to do some emotional feedback. So at that point, either the guy is smiling, that's a smile detection box, either the guy is frowning. And finally, I want to say something funny. at the end. Just need to link everything. Up. So I'm not explaining everything, but it's pretty straightforward, as you can see. Up. Okay, just so that's the case where the guy is smiling, so he should be happy. So let's say I'm happy to see that my game is making you smile. Okay. The guy is frowning in that case. Oh, sorry. It's a prototype. So let's try this. Hello.
Oh, I see you. I believe you were 31 years old and you were a man.
No.
Oh, sorry.
In fact, he's right. I'm 31, so. So it's just a prototype, but I just wanted to show you how easy is it to get into robotics app development. So what next? When you have a prototype like this, you probably want to get in a little bit deeper. And I just drag and drop some boxes, but obviously when I double click into boxes, I have Python code. So what we do in Aldebaran when we develop apps is that we start by prototyping the apps with choreographs, and then it gives us like a project view about the apps. And then we go deeper, either we double click on boxes and edit the Python code, but you can also change and go to your most favorite editors, write some C++, embed the C++ into the robot, and call your custom modules from choreograph, okay? So the last bit I could show you is, you saw that to launch that, I pressed play. But as I said, pressing play is just because I have a big and ugly wire. It's not what we want to do. So let me package that application so that it can be launched autonomously. Just need to edit what we call a manifest, put some condition in it. So maybe it's very tiny, you can't see it, but I'm just telling to the system that that application might be launched if the robot is not seeing anybody for 3 seconds. So I'm not seeing anybody equals true, and that condition holds true during 3 seconds. It's very, very simple, but just a way to put the application, to package it into the OS. So sorry, forgot to save. Okay. So here, instead of pressing play, I will just go to the view here. This view represents all the applications that are already installed into the robots. And I'm going to press that button, package and install the current project to the robot.
Please wait. I've got it. Oh, I see you.
And here I have my application. So you might think, oh, it's just the same demonstration. It was not exactly the same because I did not press play here. And I can disconnect the cable here and just have my running robot that is able to speak a little. But also, whenever he loses somebody for 3 seconds, he can launch the same application, okay? So it's a very simple thing just to give you some insight. The last thing that you want to do when an application is over, which is not the case here, is that build application package. Okay, need to save it. Edge guessing. Okay, and the last thing that the system asks is, do you want to go to the store, to the App Store, to share it and distribute it? Unfortunately, I do not have internet connection, but when you click that, you just, you are just on the website and you can upload your application. So it's a very crude application that I just designed, but it gives you a full overview from the beginning to the end of what it means to develop applications. And then, that's my last slide. Some people ask us, what is a great application? That's a good question, because obviously a great application on an iPhone will not do a great application on the robots. Maybe, but maybe not. So of course we have ideas. A great application should be contextual. I mean, should use as much of the input interfaces as possible. A good application to surprise people, should be evolutive, personalized, emotional. But in fact, and we have our own ideas, but as Bruno said, you will find better ideas and you will find new businesses. But what is sure is that developing a humanoid robot application, it's a total different story from developing a smartphone-based application. But it's a really challenging thing also. So if you are interested, join the Aldebaran community. It's open for both professional and individuals, with or without robots. Thanks. So I guess we have a few more minutes to answer your question, if that's okay.
Please.
What are some of your near-term big challenges you're working on?
Sorry?
What are some of your near-term big challenges that you're working on?
What are our short-term big challenges we are working on? The difficulty when you are doing developing robots, is that you have to gather and integrate 200 technologies. Voice, sound, mechanical, electronics, so many things. So we embedded everything in order to have a global, an overall good level. But on each and every of those applications, we can improve. So dialogue system is not good enough. It's correct, it's state of the art like Siri and so on, but that's not good enough. Emotion recognition is not good enough. It's great, but not good enough. Navigation, well, it's interesting to have your robot. You know, they are in autonomous life. So in autonomous life, the goal of the robot is to be alert whether someone wants to interact with. So as soon as he will see someone or listen to a huge sound or something, so he's turning his head, trying to see whether someone wants to interact with. So I probably, if I'm coming here, he will follow me. So our question is to improve these different things. So as of today, I would say the main challenge is to gather a community of people. Well, we're not gathering a community, but to have a lot of people interested and willing to join us, because together we will do great things. So it's more having the community helping us.
Do you have ideas about how you're going to curate your app store?
How we are going to
Curate
the App Store? Here what Gwen showed is how you can upload application, but it's not directly uploaded in the App Store. It's uploading in a test room, and we are testing, checking, and reviewing even the code. because I don't want to have people embedding some kind of improper behaviors for my daughter. So we are checking everything. So it's heavy, it's painful at the beginning. So at the beginning we are doing that by ourselves. And I don't know whether we will hire people, we will have students, we will have community helping us, or if we will be able to automatize some of these tasks. But as of today, we are doing that by ourselves.
What kind of processing power and memory you are putting in the robot?
I don't think it's very, I will tell you, but I don't think it's very important because we are changing permanently. As of today, it's an Atom, 1.6 gigahertz. But we are probably moving toward either Snapdragon or some kind of other processors. So it's something that is evolving. As for the memory, I don't know.
2 giga.
2 giga.
Because like if you want to put a lot of artificial intelligence and want to do a context behavior, then that needs a lot of data to process and then see, let's say it's working with a user. So you need to understand how the user is reacting, and that needs a lot of data to be collected and then processed, and then the behavior should come out. So it's better to have that information somewhere on the internet as a server. And this is
yes and no. To have many functions and functionalities in the cloud or in internet servers. Yes and no. First, because you don't have always internet working. I don't know how it is at your home, but for me, even if I'm in a good place in Paris, it's not always working. But mainly, some people won't want to have their robot connected permanently. Imagine, they are autonomous. That means they can walk alone in your flat. So if someone is taking control, watching your furniture, watching your security system, wow, things could happen. So that means there will be people who won't want to have their robot connected. So then all your software algorithms are not working. You need to have embedded. So of course, it will be just some level of functionalities. It will be more powerful if you are getting to cloud. But we need to have some embedded functionalities.
Like there's an option of private cloud. I can have my server running at my home in a secure environment, and then over the Wi-Fi, I can use all the data, all the processing on the client. Like that's what I do on like file servers. We have that kind of.
We don't have yet. There are many people at Aldebaran willing to have servers in the pod, kind of our own box, but we are not yet that. I'm not sure we want to do that. As for now, we don't have that. Yeah?
How the user gonna download to the robot new applications if he's not connected?
If he's not connected, he cannot download. So he has to connect just for downloading. You're right, of course.
But then you kind of exposed for that time, and any bug could get in, right?
Yeah. So that's
Another way, like maybe speaking a fluffy or whatever you want to call it.
Yeah. So you could have some Trojan spyware introduced. So we are checking, we are protecting as much as we can. But yes, at some standpoint, the user need to be connected. Yes, of course. No, you have.
Have it charge itself like a Roomba does?
Yes, the answer is yes. For now, we have a pod looking like a chair.
Yeah.
So he's looking for the chair, going and refilling its battery by himself. He's able to navigate to go there. And more or less the autonomy is depending on what you are doing around 1 hour. And for Pepper, the larger size one, is 12 hours autonomy. And able to go and refill its battery by himself on a pod, which is another kind of pod. But yes, we have that.
Do you think the hardware is now good enough where now the bottleneck is more our side, the software, or there's more needed in terms of hardware?
I think that the most difficult part is the hardware. Because imagine your computer and you are throwing it down, I don't know, 1,000 times. It's not going to resist. But when you have a robot, walking, this robot walking on a table, then sometimes it will fall down. So we need to have robustness. We need to have reliability. We need to have accuracy but at the same time, we want to have a very low price, cheap price, affordable one. So combining all that is tricky. And here we have some kind of breakdown between software and hardware for all the sensors. Do you want to have a very great camera, high resolution, and you are asking the robot to see whether in this bunch of rope is in fact it's someone who falls down? Oh, how difficult it will be. Well, I have an alternative. Let's put a thermal sensor. So we permanently have this question of breakdown between hardware that will improve and software. And if we are looking at the nature, and I like to do that, the bugs, you know the bugs, they have a very, very small brain, maybe less CPU power than in your toaster. But they're able to fly, to eat, to fuck, to whatever you want. So how are they doing that? They have millions of very bad quality sensors. But with smart, even bad quality, smart and cheap sensors, millions of them, together you can have great results without CPU power, without image analysis, without voice analysis. So we have to go to this direction. I'm not saying that we don't want to have high quality software. We need, and there are many, many things to be improved. But for the software, I'm sure they could have thousands of people, hundreds of thousands of people who will improve that. So for me, it's easier because of the communities. When as for hardware, it's much, much tougher. Okay, so sorry, I'm out of time. They're beginning to move arms. Is it okay? So I'm sorry, I have to stop now. Thank you so much.